accept a word like infinite right now. But the V segment of the alpha chain has up to 70 or a little over 70 potential segments that it can include for the V variable here. The alpha chain also has 61, I wrote these numbers down over here so I wouldn't get them wrong. There are 61 potential joining segments that you could include in your alpha chain. And if you do the math on that, for the alpha chain here, that's, what would that be? 70 times 61, which is 4,200 plus 70, 4,270, I suppose. That's 4,270 potential combinations here on this alpha chain alone. Now on the beta chain, you have 52 potential V sites you could encode here, 2 potential D or diversity segments you could put here, and 13 J segments you could put here. Now doing the math again, that would give us 104 times 13, so that's 1,040 plus 304, or 312. I don't know what that comes out to, but that's a pretty big number, sort of. And if you take that number and multiply it by this number, and I've already forgotten all the numbers I said, the point is, when you multiply all of this together, that it comes out to a huge level of potential binding site capabilities. And that's just for T cells. So we haven't even gotten to B cells yet, but this variable diversity joining system is what offers the genetic diversity to combine with so many specific sorts of epitopes that exist in nature. And T cells can also differentiate into a bunch of different classes, like we saw with our antibodies in general. After T cells become mature, they have to differentiate. They're clones of each other, meaning that they are genetically identical. But like in the same sense that our eyes are genetically identical to the cells in our hands, but they perform different functions because of the way the genes are transcribed and translated and regulated. The same sense, T cells can be genetically identical, but they also serve different functions depending on where they are in the body and how they differentiate, how those genes are activated. First class, one you've probably heard of, is our helper T cells. Helper T cells express CD4 on their surface. CD stands for cluster of differentiation, basically a group of proteins that affect the way that these T cells function, act, bind to other cells. Helper T cells express CD4 on their surface, just a particular group of proteins that are activated by MHC2 antigens. Recall I mentioned earlier that there are a couple of types of major histocompatibility complexes, and helper T cells interact with MHC2 in order to activate and direct humoral and cellular immunity, strengthen natural killer cells, and the functioning of macrophages. So if you're confused about why we're bringing in humoral or B cell immunity into the T cell conversation, this would be because T cells regulate not only their own functioning, but a lot of B cell functioning as well. B cells can function as T-independent immune responses or T-dependent immune responses. Later on, we'll talk about T-independent responses, but for T-dependent responses, helper T cells play a regulatory effect in that those interactions, which is to not be even more confusing because the next type of T cell is the regulatory T cell. Like the helper T cell, a regulatory T cell expresses CD4 on its surface, is also activated by MHC2 antigens, and instead of being involved in humoral and cellular immunity, instead of being involved in native killer cells, the regulatory T cells are going to be regulating the peripheral tolerance and the prevention of autoimmune responses. So again, this does relate back to our thymic selection and the ways that early on there, we want to remove all of the cells that are